And welcome back as we go ahead and continue looking at different things for helping us write better programs. Today specifically, we're going to look at the technique known as preventative coding. So with preventative coding, we have different ways that we can kind of approach this. So first off is just to think about when we are looking at debugging, for example. When we talked about, different techniques that we can use using things like trace statements, and recall we said if we use trace statements, they can be laborious and time-consuming. Even if we start using different things such as our summer debugging techniques, they of course can still lead us to having to do lots of things that we gotta work through for each step. So a better way is obviously to prevent errors, is avoid making the mistakes that could lead to those errors in the first place. So we use what's called incremental development in order to write and test our code. This means rather than try to write our entire program all at once and then test it, we code a small chunk of it, see if that chunk works, and then code some more. And you may have already actually been using some of this approach without realizing. You might have wrote, hey, I'm just going to get input first, test it, make sure that's working, then I'm going to do like a loop or something like that. Again, this is something you could already be using, and if you're not using it, it's not a hard transition to do. Another thing you can do is, of course, have other programmers look over code with you. If you're sitting in a classroom, you can have like an elbow partner come over like, hey, look at this and make sure my code is working the way it should. You can work together, do like a back and forth compare programming in order to develop a good program. They can also help you with code review to immediately spot errors in your code. Because a lot of times if you're just looking at your code for a long period of time, you kind of become blind to potential errors or issues within your code because you've been looking at it already for so long. A fresh set of eyes can help. So let's do a quick overview of incremental coding. How would this actually work in a programming scenario? Well, let's do this by examining it through a programming problem. We're going to say we want to write a program that's going to start with 1, add all the integers after it up until including a certain number. Then a number should be determined by user input, and the number inputted should not be less than 5. All right, so when we look at this program, we can determine a few things. First off, we need to define some variables. We're going to have to get user input. We're going to need to determine the number size because we want to figure out how many numbers we're getting in. And lastly, we're going to use a loop to add up these numbers. So we're going to use this incremental approach to address each of these bullet points here. Let's first off start with the first one, which is defining the variables. So when we look at the variables here, we're probably going to have about 3 of them. One that's going to get the user's number for the upper bound. We're going to have one that's going to keep track of the count of the loop, and one that's going to keep track of the sum. So let's go ahead and declare those in our program. So let's use int number, a loop count, and sum equals 0. And so here in my program, let's go ahead and add those variables we just talked about. So we have int, and we have user input. We have the loop count, and we of course have the sum, which equals 0. All right, and that's our variables right there. So now we can of course keep looking at what else do we need. Well, the next thing is getting user input, and we know how to do user input fairly easily. We've done this plenty of times before. We're simply just going to use the scanner object, and so scanner KB equals new scanner system in, and we're going to say number is equal to kb.nextInt. And so let's go ahead and put that in here. Let's import java.util.scanner. And let's go ahead and set these up. So we'll use the scanner kb equals new scanner. And we're going to make that system.in. And we'll use user input equals kb.nextInt. All right, so at this point we have our program set up. So we can, of course, test our code with a simple print line statement to determine if the program is capturing the value we want, which, of course, that value would be, in this case, number. Remember, there are 3 variables that we are really keeping track of. So number, loop count, and sum. I think I called it user input in our program, but that's okay. But what we ultimately are going to end up doing here is making sure this program works, because this is about half of our steps, so this is a good point to stop with our incremental approach and test our program. So let's go ahead and add that test statement here. So before I do that, I'm just going to add in my prompt here to tell the person to enter a number. So please enter a number for the upper bound of the sum. And then we're just going to go ahead and verify this through an echo statement. So a system.out.println, you said that you want user input as the upper bound. All right, just a quick echo statement here. So if we run this, we're getting please enter a number for the upper bound of the sum. So let's just say we want to do this as 10. And we get, you said that you want 10 as the upper bound. All right, great. So that means that our input is working as we expected. And this is something, of course, that we later we can say, we don't really need to have this statement here. We can just comment that out because, this is just for testing purposes right now. But right now we really want to keep going and see what else do we need to do. So if you look, we still have 2 steps left. We have determine the number size and use a loop to add the numbers. All right, and as we mentioned, we are getting our input as expected. So let's move on to the next piece of code, which is going to kind of start getting to the bulk of things. All right, so determining number size. Since we do not want to, let's say, proceed on with our code, we need to add a conditional branch that's going to close the program at some point, right? Because at some point we have to say, hey, if it's a certain value, we're going to want this program to terminate. The best approach, of course, would be for us to use an if-else statement. So we can say, for example, if number is less than 5, system.println, the number is too small, system exits 0. And we can do this even though we haven't yet made the looping part, because notice we're not using a break here, we're using system.exit, which means this is going to close out of the program completely. So let's go ahead and add that in here. So if this is user input is less than 5, because this means the number is too small, we're going to go ahead and do another system.out.println. The number you entered is too small. System.exit 0. Perfect. And now you notice we have our last step, which is using the loop to add numbers. So let's look at how we construct this loop. Well, with this loop, we can use either a while loop or a for loop to solve this task. For this example, let's go ahead and look at this through the lens of a for loop. We can say for the count loop is equal to 1. Count loop is less than or equal to number because we want to go up to that value. Count loop plus plus. And we'll go that sum is equal to sum plus the count loop. All right, so let's set up our loop. So we got 4, and we're using the loop count. And we're going to initialize that to 1 because this is a variable that exists outside of the statement. We, of course, could put this loop count initialized as something inside this loop, but for now we're using this 1 up here. And we want this, of course, to be set up so that the loop count is less than or equal to our user input, because remember, this is our upper bound. And then, of course, we need to increment loop count. And then we just get our sum. So sum equals sum plus loop count. And there's our program. So obviously this looks like it could work, but we cannot forget that we still need to test our program. This is a very important step. Just because, oh yeah, the program looks good, we should test it. All right. And while we should be testing our program with each step, don't forget that after our program's already done, do one final test to verify the program's execution is working as intended. Remember to test using multiple inputs of different values to determine if there's some case that could cause our program to fail. So just to drive that point home, let's go ahead and run this program one more time. So we're going to put in the upper bound, so let's use 10. And notice the program terminates, but there's no output. And this is where doing that final test is really important, because we realize, oh, we never actually spat back out what that sum is. And so I can easily now come in here and say I missed that, so I can do system.out.println. The sum was, and just concatenate in sum. And now if I rerun that program, let's put 10 in, we get the sum was 55. Awesome. But what's if we want to test this with other values? Let's just make sure, for example, our if statement works. Let's put in a 4, because 4 is less than 5. We get the number you entered is too small. Great, so that's working. What's if I entered in a number that was really large? Let's say 1,000. And you see, we get the sum was 500, 500. So you can see, again, these things are working as they hopefully should be. And I'll just do one more test here. Let's test this with a negative value instead. So let's try something like -3. All right, and you can see again, -3 is smaller than -5, so we get the number introduced too small. So this is, of course, is working excellent for what we want to do. And again, this is all done with some preventative coding to make sure that we can meet the objective that we outlined here within our program.